Alright, welcome back. We're on homework 3 for Thermodynamics II at South Dakota School of Mines and Technology. This is problem number 4. Homework number 3 is partial molar properties, which has both graphical approaches and analytical approaches. And as you can see by my beautiful graph here that this is a graphical approach. Okay. Now I don't obviously have a lot of room for equations, so I'm going to have to kind of erase things. Okay. But it's asking for, well, all the standard stuff. This one's different. This one's different because I don't have V as a function of mole fraction. I have partial molar V as a mole fraction. Okay. So it really invokes the numeracy of graph. Okay. And this is a subcomponent of numeracy called graph literacy. Okay. But there's no, it's not Giffercy. It's just graph literacy. Okay. Can I translate from the math to words to graphs? Okay. And I have to remember what the math says in words, and then from words, what does the graph say? And get them to mesh up. Okay. So let's just go through things one by one. It says I want V1. Okay. Well, first, okay. So what does V1 say in words? It says the volume of component 1 is a pure system. Pure system. What does that mean? It means there is no other anything else. It's just 1. But mathematically, what does pure system mean? It means that x1 is equal to 1. And because this is a two-component system, if it's a two-component system, what does x2 have to be by default? That's right. And so I just read the graph. I just read the graph and say, where's x1 equal to 1? It's equal to 1 right there. Well, Dr. Hadley, I have 2 lines. True. Oh, for those folks at home, sorry, well, those are folks at home that aren't in my class. This is from Milo Koretsky's Thermodynamics book, 2nd edition, 6.47. So, if you don't have the solutions, well, here you go. Anyways. So, but what we're trying to do? Okay, we're trying to get, well, it's the same graph, but not the same problem. Okay. So, V1, okay, so this is not the solutions if you are not in my class. So, V1, okay. So, partial molar V1, sorry, not partial molar V1. V1, volume of component 1 is a pure system. This, okay. Well, I have 2 things. But I also, so I have partial molar V2 and I have partial molar V1. What do they say in words? The contribution to the volume from component 2 in the mixture. Okay. Well, if there is no component 2, can 2 contribute to the mixture? In a sense, yes, but we're not going to really get into that probably today. Okay. But really, I mean, if I want to look at the contribution of, if I want to look at the contribution of 2 or contribution of 1, when it comes to V1, I probably care about V1. That's V1. So, I mean, yes, I have 2 choices at x1 equals 1, either this one or this one. The only one that makes sense is this one. Okay. Because, I mean, that's what, and because remember, from the analytical ones, that partial molar V1 goes to V1 when it's pure. Okay, well, partial molar V1 went to V1 when it was pure. Okay. What about V2? So V2, the volume of component 2 is a pure system. That's what it reads, which means that x2 is equal to 1, which means x1 is equal to 0. Okay, so on the graph, where's x1 equal to 0? Or rather, x2 equal to 1. Over here. Okay, so I'm either looking at this point or this point. Now again, I didn't draw this right, so in the real picture they do intersect, so it's not like I don't have an intersection for this one. But it wouldn't matter, because I want to look at that bottom curve anyways, because I care about component 2. And so this one is V2. It's because V2 goes to V2, partial molar V2 goes to V2 as X2 goes to 1. Okay. Again, that's what the math says. Okay. So V1, V2. Partial molar V1, partial molar V2. Okay. Okay. Well, what do I do there? Okay. Let's see here. It gives me a molar fraction. It says x1 equals 0.7. Okay, so then let's say this is 0.7. Okay, so that's V1, but where's V2? V2's right there. It doesn't matter where, it's not. So if this is x1, it doesn't mean I go to 0.3 for V2. I go to x1. Because this does not say that x2 is equal to 0.3. It says x1 is equal to 0.3, and is x1 equal to 0.3? No, I can read on my paper, it says x1 equals equal to 0.7. So it doesn't matter, I gotta look at what the axis says. It says x1. And so that's where partial molar V2 is, and that's where partial molar V1. I just read the graph. I don't go to 0.3. Okay? 0.3 has no meaning in this problem. And I know that might seem counterintuitive when I think about this, but I got to think about what is going on in these two situations. As it goes to a certain number, it's as x1 goes to 0. I still read x1 equals 0. I still read x1 equals 1. But as x1 goes to 1, only one thing has meaning, v1. So to get partial molar V2 and V1, I just read the graph at 0.7. I don't do anything goofy. All right, volume. Well, there's no volume on this graph. We can't do it, Dr. Hadley. But this is numeracy. I have graphs, I have words, and I have math. And do I have an equation that relates V to partial molar V? So I'm given partial molar V's. Do I have an equation that relates V to partial molar V's? Okay, I have a couple. I know that partial molar V1 is equal to capital V, D capital V, Dn 1, T, P, Nj not equal to 1. But that's not little v, is it? No, that's capital V. And, and what I would have to do, because I'm given V1, I'd have to integrate that. Do you think I can, do you think I can eyeball the integral on this thing? No, I really can't. Okay, so an integral, that's not really what I want to do. So I got to think about another equation that relates partial molar properties to little v. And that's the other one I need to memorize. Okay. I need to know, what does partial molar V1 say? It says how much is component 1 contributing to the mixture volume. And if this is contributing, and this is contributing, I have the mixture volume. I have a contribution from component 1. I add that to the contribution of component 2, and I have the volume. And if I read it in words, that's what that says. And my generic equation, though, is just that little v is equal to summation of xi partial molar vi. Okay. So, well, do I have v1? Partial molar v1? Yeah. Do I have partial molar v2? Yeah. Do I have x1? Yeah. Do I have x2? Yeah. Can I plug that in? Yeah. And I don't read the volume from this graph. I read all the components that go into the volume from the graph, but I don't actually read the volume from the graph. I can't get that from the graph. I have to plug it into the equation. I have to use the math to get it. Okay. All right. Delta V mix. Okay, so I have to remember what that one is. Delta V mix is, well, how much does the volume change upon mixing? Meaning, okay, well, what is the volume of the mixture minus what it would be as if they mixed ideally? So, delta V mix is equal to V minus V ideal solution. And what's V ideal solution? V ideal solution is equal to X, summation of Xi, Vi. Okay. Do I have X1? Yeah. Do I have V1? Yeah. Do I have X2? Yeah. Do I have V2? Yeah. Do I have V ideal solution? Well, after I plug it in, do I have V? Yeah, I have right here. That one minus that one. Can I get it from the graph? No, but I have the math. I don't need it. So I can just plug it in. And then, well, I'm done. So, nothing crazy. What is crazy about this problem is that it's different. And different is not the, you can't focus on what's different. You gotta focus on what does the graph say? What does the graph show? And what do you know about variables in the math that relates to what the graph is saying? I have this stuff that this is what the graph is saying. I have to remember that that graph is associated with some math, okay? And that they're not independent of each other, okay? I have to remember that this has mathematical meaning somewhere else. And that's where I can get all the rest of my information.